Okay, this is the controversial question I sent to my Facebook page, and I think only one person got the answer correctly but couldn't provide a solution. So here's a question here. It says a rectangular block of wood floats in water with 2/3 of its volume immersed. When placed in another liquid, it floats with half of its volume immersed. Calculate the relative density of the liquid. And I have some options here. Option A says 1.43, B 1.33, C 1.00, D 0.83, and E 0.75. So in this question, you might provide a diagram that will help you. So getting the diagram helps explains the question well. So first of all, they said a rectangular block of wood floats in water. So if it floats in water, and also it floats also with a particular percentage of the volume immersed in another liquid. So here is a diagram. So let's assume that this is water. So this is water. And this is the other liquid. So interpreting the question, this is the rectangular block before it was being placed in water, and now it is floating with a particular percentage of the volume or fraction of the volume in the liquid. See, it's not completely immersed. So, but we know that the density of water, of this liquid water, is equal to the mass over volume. Now, what is this mass? The mass is the mass of the displaced liquid, because once this rectangular block is being placed in this water, the level of water will increase a bit. So the mass of that displaced water is what we have here, and the volume here is the fraction of that rectangular block that at least entered into the water. So we know that it is half of this volume, because in air here we know also the material is also equals to density equals mass over volume, and here the volume is complete, nothing like half is being placed in air or something like that. That would be absurd. So they now said 2/3 of its volume was placed here. So that means the volume is now 2/3 of this. And of course, 2/3 of this V means 2/3 times V. And that will give us 2V/3. So that settles it. So that means the fraction of this volume that entered, we can even see it from here, that is not completely inside the liquid. It's just 2/3 of this complete volume in air. So it's just 2/3V. Then the mass of liquid displaced we don't know yet. So the mass of the liquid that was being displaced upward, leaving the former gauge to a new gauge, we don't know that yet. But we know that since this liquid is water, the density of water is 1000. Density of water is 1000 kilogram per meter cube. That is sure. So I'm placing 1000 here for the D. So I now have 1000 equals to this mass that we don't know over 2V/3 rather. Then I can find the value of this mass by making it the subject of the formula. So I can put this 1000/1, and then I'll cross multiply. M times 1 still gives me M equals 1000 times 2V/3. What will I get? So 1000 times 2V/3 gives me, so 1000 times 2V/3 is equal to, I can put this 1/1, nothing can cut out, so I have 2000 V/3. So that's it. So I'm going to have, this time this gives me 2000 V/3. And mind you, since the object floats, since the object is floating in water, it means the mass of the object in air will be equal to the mass of the liquid displaced. or the weight of the object in air will be equal to the weight of the liquid displaced. That if you can convert this mass to weight, and you know that once you convert this mass of the liquid displaced to weight, you have actually gotten the upthrust. You have actually gotten the force that this water is exerting on the particular solid. So now that we know that this guy and this guy are the same because the object is floating. So let's just keep that one and have that in mind. Now the second, we know that this and this are the same, and it will come in handy now. This is the second liquid, and let's call the liquid Y. So the liquid Y, the density of this liquid, we don't know, let's call it Y. Density of the liquid, we don't know it, but we know the one of water as 1000 kilograms per meter cube. But the one of this other liquid, we don't know it, so we're going to call it Y. We'll say Y equals mass over volume also. So what's the volume? They said only half entered, and as you can see, it's not completely inside the liquid. They say half of the complete volume. So half of this complete volume, that's 1/2 times V, that's half of V, and we'll now have V over 2. So we'll have V over 2. So that means I'm going to say mass over V over 2. We still don't know the mass of liquid displaced because, of course, some liquid will be displaced upwards, and that will be, when you convert that one to weight, it will be the upthrust that this liquid is also exerting on this particular object. And again, they give you the key word that this object is also floating in this liquid. It also means that since it's floating, the mass of the object in air is equal to the mass of the liquid that is being displaced. So let's make this one the subject of the formula also. So I have Y equals to m over V over 2. Then I'll cross multiply. M times 1 gives me m, equals Y times V over 2 gives me Vy over 2. So now, this equals this, and this equals this also. And after simplifying this, I got this. So if this is equal to this because it's floating, and this equals to also this because they're floating, it actually means that this mass, value of the mass we got here, is equal to the value of the mass we got here also. So that is it. It also means that this mass is also equal to this one. So we are going to solve and make Y, because Y is the value of the density of the liquid, the subject of the formula. So we are now going to say 2000 V over 3 equals to Vy over 2. Then, of course, I can say V cancels V. I'm left with 2000 over 3 equals to Y over 2. And I can now cross multiply. Y times 3, that will give me 3Y equals to 2000 times 2, that's 4000. Divide both sides by 3. 3 cancels 3. Then Y equals to 4000 over 3 kilograms per meter cube. So that's the density. That's the density of the liquid. But remember how we did it. You have to equate, since the mass of the rectangular solid in air is the same as the mass of liquid displaced, mass of water displaced, and also since this one is also floating like this, it also means that the mass of the solid in air is also the same as the mass of the liquid here displaced. And since this equals this and this equals this also, it also means that this is equal to this. So since this is equal to this, I made this one the subject of the formula, I got this. And I also made this one the subject of formula, and I got this. And that is to say this is also equal to this. So equate them together and make Y, because we made Y the value of the density we are looking for, make Y the subject of the formula. And that was what we did here. And we got our final value for Y. But they said we should find the relative density of the liquid, not just the density. And of course, you know that relative density must also be the density of the liquid, density of liquid over the density of water, so that will be 4,000 over 3 is the density of the liquid divided by density of water, which is 1,000. Remember, when they say you should find the relative density of any liquid, it means you are relating the density of that liquid with the density of water, since water is the most common liquid. So that's why I'm dividing it by 1,000. So you now have, spreading it, you now have 4,000 over 3 times, you are going to swap this one, times 1 over 1,000. So 3 zeros cancels 3 zeros. I end up having 4 over 3. And if you divide, that's approximately 1.33 as the value. So the answer to the question is actually 1.33 and not 0.75 as some of you were guessing. So it's very simple.